So the first chapter, guys, let me just, because you're not familiar probably with the book that you have in front of you is, I believe, one of the best books that written about residential wiring and the codes for residential. Granted, you guys are not electricians, so you're not going to do a whole lot of installation, most of you. We're going to take the electrical part, the code part of it, and apply it to apartment buildings, which you would be involved in designing a power system 208, 120, or 240, 120 for an apartment building. So if you're asking me why are we doing residential, only 6 weeks, by the way, we're doing it. We're not doing it for a long time, but it's because you will be involved in residential, some type of residential. So it's good to know the residential code, the part of the code that talks about residential. Okay, there's a couple of chapters. This book guys follow a house, as you know, and there's designing the house, layout of blueprint for a house, step by step. What do you need in the bedroom, living room, kitchen, basement, and so forth. So we're going to be picking up certain chapters from it. But the first chapter, when you guys are electrician, the first chapter you need to know about is safety. So here's the nice thing. This one, if I can move it. This is my new. There you go. Move it a little bit here. So a couple of objectives. These are coming directly from the book. The first thing I would like to do, guys, talk about safety rules, and I will let you know, guys, why we talk about safety rules as designers. We're not electricians. For electricians, we will go deep into the safety. We'll talk a few things about safety. The first thing I showed you guys is a bunch of internet access, internet sites that you need as a designer to be able to go there, access information, find switchgear, switchboard, and so forth. The first thing I gave you, remember my collection and my, what do we call them, my favorites. So these are very, very important to be able to get unlimited amount of resources about safety and everything else. So these are a few things that this chapter covers. Codes. In the state of Minnesota as well as the US, guys, we use the National Electric Code. I'll talk about safety in a second. I summarize it in four things, safety. But the first and the most important thing you need to understand is the National Electric Code. We design and install every system based on NEC code book, and that's what we're going to be going through over the whole year with Chet. So that's one that you guys are familiar with. It's called 70, NFPA 70. There's when you become a project manager, there are two very important documents, 70E. This is safety, working safe around electrical equipment. Talk about arc flash, arc blast. How do you work safely around electric equipment? This document is unparalleled. This is typically if you work for electrical engineer, electrical contractors, and you become a project manager, you have to be very familiar with this. Or for you guys, if you're electricians and you're going to be working as an electrician. Big deal. We train 70E. They call 70E training here at Dunwoody. If anybody's interested, I do have a 4-hour presentation about 70E on my YouTube channel. So go ahead and watch the whole spiel if you want to.
Is 70E in addition to NFPA 70 or 70E?
70E is a completely standalone document. These are, guys, completely standalone documents. So the first one you need to be aware of is 70, which is, you're looking at it right in here. The second one you need to be aware of is 70E, only if you become a project manager. If you work from Scheid Cooley Erickson or any other places as a designer, not a whole lot of knowledge you need to know about that one. The third one is this document. Very few people know this document, 70B. This is maintaining existing electrical system. How do you maintain safely existing electrical system and have a preventative maintenance for your electrical system? That's also if you become a project manager. When we teach electricians, we go deeper into that document because you have to maintain the system. Big deal. This is for inspection, not a whole lot, but these are the most important documents that you guys are going to be involved with. OSHA regulations is tied directly electrically wise into 70E. So if I am to summarize three very important documents for you guys, it's going to be NFPA 70 and 70E. Plus ADA, American with Disability Act. This is a big deal. When we design systems, you need to be, people with disability in a wheelchair, be able to turn the switch on and off, so you can't put the switches here. So when you guys work for Scheid Cooley Erickson or any engineering firm, you're gonna find a lot of rules for people with disability, ADA, American with Disability, American Disability Act. So that rule becomes a big deal. We'll talk about licensure in the great state of Minnesota in a few seconds here. So these are few things. We talk about the International Association of Electrical Inspector and what do we do for the industry and so forth. And then metric system for units. These are a few things that we're gonna touch on. Here's how I summarize safety. And some of you might wonder, guys, why do we care, right? You're a designer. I'm not gonna carry the tools. You will be around electricians at all times. If you're a project manager or an engineer designer, you go to the field. You told me, Joe, you've been in the field many times. You could be very involved in the safety. If you are dealing, here's how I summarize safety. And a lot of people summarize it with 4 steps. Safety start, guys, by safe products. How do you get safe products? Safe products that get you out. That's why we have safe product comes with designing a product that's safe. Who can make sure that the product is safe? You are. I can't. I don't have a testing equipment to test that the switch gear is going to be able to handle the short circuit. Safe product is safety. Start with safe product. Number 2, start with the design. That comes NEC. Now we have a safe product. We put them in a building and we design a safe system. And who helps us with the safe system? NEC. So now we have a safe product installed safely, designed and installed safely in a building. That's step 2 of the safety. Step 3 of the safety is 70E. 70E, guys. So most of you are going to be up to this point here. 70E, when you become a project manager, you have a group of electricians working for you to maintain electrical system. They have to be able to work safely around and on electrical equipment. That's where 70E becomes a big deal. There's the boundaries and a bunch of other things, the arc flash, arc blast, how do you avoid it, PPE, the PPE that you have to put on. That's step number 3 of safety. Step number 4 of safety is 70B. These are NFPA 70B. 70B will tell you, if you have a building like Dunwoody, how do you maintain the ballast, the light, the receptacles in the building, maintain preventative maintenance so they don't fault and become dangerous for the people who are around them or the people who are working on them. So these are basically the 4 steps of safety. You can see we start with UL, safe equipment, NEC, safe design and construction, then 70E, safe working practices around and on electric equipment, and 70B, preventative maintenance, so the equipment that we work on is not going to blow up. So that's kind of when it comes to safety. You guys know if you're around electrical equipment, you are exposed to 2 types of hazards. Electrocution, we're very smart not to. So when you go to a place as an electrical designer, never ever stick your finger where it doesn't belong. You guys, as a matter of fact, yesterday I stopped by C Electric. They have a little project here. They want to modify it, and the electrician opened a 400 amp, 240, 120, 3-phase center tap delta disconnect, and you're staring right at big cover and the fuses. And I'm not carrying tools. I was there because we want to add a generator to the plant. So I was thinking, wow. So when you're not carrying tools, you're just there to modify the system. So if somebody's to drop a wrench right there, you are exposed to arc flash. What's an arc flash? An arc flash, you will go home with no eyes. That's what an arc flash, or a burned face. So not one of us want to go home with no eyes or a burned face. So be very aware, guys. Yes, we're not electricians, we're designers, but we're directly involved in the arc flash, arc blast.
There was a guy at 2 years ago that pretty much did exact that with a wrench, saved phase, and you can go home and all.
Yep, he passed away. So it's a big. My advice for you, and I go deeper with the electrician, but since you're not electricians, my advice for you: first, don't stick your fingers where it doesn't belong. Second, if an open panel is there, try to get your pictures, whatever you need, as fast as you can, and move away. Move away at least 10 feet away from that open panel. The boundary is 4 feet. Boundaries of arc flash typically is 4 feet unless you calculate it. But 10 feet is the safest. 10 feet is you will go home with nothing on you. 4 feet you might get burns. So big deal. Electrocution, don't touch things. Arc flash, stay away at least 10 feet when the equipment is open, especially if you have no business of being there. So don't enter it. So it's a big business.
I got some nice pictures of long pieces from Minneapolis.
Yeah, thank you. You can share them. Email them to me. You can share them with us. Electrical safety, guys, this is typically for electricians, but here's when we do 70E, if you guys have a chance to watch my presentation about 70E, the rule is you work on electrical equipment de-energized. This is rule number one. You de-energize the system when you work on it. When you de-energize it, you safely de-energize the system. We safely de-energize the system by what we call it lockout tagout procedures. You push the button, that button here, you de-energize the air handling unit. Second, you put the disconnect in the off position. Third, you lock it with your lock, and you put a tag there that has your name on it, and you take your key with you at all times. And then you work, and then you go measure that there's no voltage after you lock it. The procedure goes, you have to verify that no voltage. You measure that there's no voltage on the equipment, face to face, face to ground, and all of them. And then you can work on the equipment. So that's kind of a lockout tagout procedures. That's a rule. The exception is working on things energized. When you work on things energized by 70E, you have to have an energized work permit. Tons of people have to sign it. You have to verify why you need to work on it. So it's a big deal. Why am I saying this one? For a project manager. When you become a project manager, you want to work on a system energized, be aware that there is a work permit, energized work permit you have to fill, and be aware that you could lose your house if somebody got killed that day. Just be very aware of that one. So that's where your lockout tagout procedures, physically restraint of all the energy sources. And safety, as I said, is the law, because you could lose easily your house if you neglect as a project. Typically this is for a project manager when you become project manager. So you have to be aware that you have to work on things energized. If you are to work energized work permit, number one, and you have to justify why can't you work on it de-energized, and you have to follow all the procedures for that one. Good housekeeping, guys, we all can benefit from that one. When you work energized or de-energized, you could fall on anything and hurt yourself. So who cares? You're not going to be working. You are the project manager. You could be easily the project manager there. So make sure you adhere to this one. Lockout tagout procedures, work permit energized, and good housekeeping. Any comments, guys, about these? Yes, sir.
If you're a project manager, whatever, bidding on jobs, if safety records too high, most places will let you bid on jobs.
Absolutely.
So that goes for contractors.
Losing job. So if, you might not lose your house, but you lost your job too.
You want to get the chance to bid projects.
Yeah. We do a lot of safety training, guys. It's unreal. I don't want to even go there. Yes, sir. Jeff, you have something?
Oh, no, I was gonna add in that was like people when that guy died, that's why they almost went under because they couldn't bid on stuff.
Yeah.
So.
Yeah. And that apprentice who died for People Electric was done with regret, by the way.
That's the one I'm talking about.
Yeah, the same thing.
Yeah.
A couple of years ago.
Yeah.
So it's a big deal. Why we're telling you guys this one? Because you are a project manager. Designers don't see this, but you will be some of you will be project managers. So it's your responsibility to, by the way, it is your responsibility as a project manager to provide a safe working environment for the people who work for you. Legal responsibility. And it's your responsibility as a project manager to stop people from doing things that's not safe. It's your project. Okay, live parts. If you are to work on energized live parts, you have to be qualified. And the code defines qualified person. Big deal. No license here. I don't think you're going to see any license. Qualified people, you have the skills and the knowledge of the construction and operation of the equipment, and my favorite is, has specific safety training, have received the safety training to avoid and recognize the hazard. So you have the skills and the knowledge. I know how a 4,000 amp switch gear is constructed and how it's operated. That's the knowledge and the skills. Second, I know what an arc flash would do to you, or an electrocution would do to you if you stick your finger or if you drop a wrench in a 4,000 amp switch gear. You're a qualified person. In the state of Minnesota, qualified person, most likely 99% of the time, at least a journeyman electrician. But you don't have to be licensed though to be qualified. So if you're not qualified, you cannot work on anything energized. Done, period. In our state, you can't work on anything energized or de-energized electrical unless you're supervised, as we all know, by a licensed electrician, right? So at all times. So that's a big deal, guys, for you as a project manager when you walk through. PPE. PPE, when you work on energized equipment, they call them the PE, personal protective gear or equipment, that will be a couple of things. First, you have to have gloves for electrocution and the arc. Second, you have to have a shield to shield your face, and a shoes, of course, or boots. So these, and glasses and hard hat. Hard hat. Typically, these are, and again, I don't want to go too deeper into that one, guys. If you want to look at my presentation, you'll see a lot of pictures of people have the shield and the hood and all this good stuff to protect you. You can't work on anything energized without at least glasses. There's categories of hazard from 0 all the way to 4. 4, it's like somebody coming from a different planet. All this big hood. Category 4 is as the worst of the worst. Higher than 4, you cannot work on an energized period. Done. So be aware of that one as a project manager, the PPE, the proper PPE. You as an employer, in this case, you'll be the project manager. You're supposed to provide the PPE, like People's Electric. The PPE, for this, my understanding, was in the car, but he decided not to pick it up, or that's at least the story that I heard. But there was a PPE on site for him to put. You guys are familiar with the PPE? You put all this hood and glasses and all the stuff when you work on things energized.
Yeah.
All your rings and all the stuff, leave them home. This is an excuse, Jamie, not to get your ring when you go work as an electrician. You tell your wife, leave the ring at home because I'm working on energized objects, I always say. So you don't want to be more conductive than you need to be. Any comments, guys, about these? Any comments about these? What's in it for you? You're a project manager. That's the most important thing, guys, for you. Project manager, you're going to be a project manager. You're not going to carry tools, most of you, but project managers. When we work on energized objects or equipment, there are 2 hazards. Hazard number 1, electrocution. That's why when we go 70E, guys, we have the boundaries. We have limited approach, prohibited approach, and restricted approach. These approaches that you're supposed to, most of them within 4 feet. You should not be within 4 feet of any equipment that's open energized because of all these electrocution. The second hazard is arc flash. What's arc flash? You drop a wrench, big ball of fire comes out of it, and hits you in the face and burn your face. So because of that big explosion that you can get. So arc flash is big deal. Be aware of that one. When you work on electrical equipment, services, everything, assume that arc flash can come from everything else, guys. Look at the temperature that arc flash can get. I don't want to go too much into that one, but on arc flash, imagine, guys, first of all, the heat, you're going to be burned by heat. Second, you're going to have a wave, they call it wave, that's going to push you off the ladder. A wave that push you off the ladder, coming out of that arc flash. Third, you're going to have little melted cover, like bullets shooting at you if you have an explosion. So if you survive all this, the bullet's going to hit you. Third, you're going to have a big light that's going to blind you. You can't see because of the rays and they're coming out of you. And the sound is going to deafen you. You can't hear anymore. So you can't hear, you can't see. Bullets are chasing you. Big fire is burning around you. And somebody's pushing you with I can't remember, was it 60 miles per hour getting a push. Talk about bad day. So that's the reason why I say that, guys. We're not electricians, but you will be in a situation like I was yesterday, right staring at open panel with a 400 amp 480 240 phase system or more. So be very, very aware of it. Any question, guys, about the arc flash? Just be aware. Always don't be, if you have no business, especially when they open a panel. You have a panel like this standing over here, guys, no problem in front of it. The minute that you open this box and you're exposed to the energized, if you have no business, move away. As a matter of fact, a good journeyman will move everybody away. The public have to be removed. You have to barricade yourself when you're working on energized equipment. There's rules. And take it very, very serious as designers. So, okay, for arc flash, there are 2 things that threaten your life, guys: times and current. So when you for electrocution or arc flash, the higher the current and the longer the current stays, the more big ball of fire is going to chasing you, and more bullets is hitting you. Big deal, So if the current stays longer, this is a big deal, guys, for us. You might thinking when we start doing power analysis, Jamie, later on, you guys are gonna do arc flash analysis for me using the software. You're gonna do an arc flash analysis, and you're gonna put a fuse, a current limiting fuse, and the arc flash is this level. and you're going to remove it and put a non-current limit fuse, and the arc is going to be that level. You're going to see it right with the calculation. How the faster the fuse opens, and the smaller the amount of current, the less big ball of fire is going to chase you in an arc flash. So it's big deal. Okay, electrical injuries. You guys are familiar with that one. We have electrical. You get an electrical shock. You shock and let go. Electrocution. Now you turn yourself into a bulb, and the rest is history. And you can have burns because of arc flash, or you can be pushed off the ladder because you got electrocution and you were shaking and you pushed off the ladder. So no electrocution, no problem, but you fell off the ladder and you broke your neck. So again, I usually go deeper with the electrician guys, but you're not electrician, you are a designer, but you will be exposed to most of these hazards as well. You are in the field with electricians, especially when you become electrical project manager. Any comments, guys? Any questions about this? Again, if we're doing OSHA, we'll do, and training, we do a lot of other stuff. Electrocution. As a project manager, when you become a project manager, you need to at least, if you need to know, well, what do you do if you see somebody being shaken like this and being electrocuted? Right? You need to be able to call 911. When I remember when I was doing electrical work in Jerusalem, the rule was, we've been told, is you have a 2x4, you push them as hard as you can, but don't make sure you push them in the head and kill them too, away from the source of power. The last thing you want to do is grab on them, right? You become part of the electrical circuit and you die too. So you need to de-energize them as soon as you can. The proper way of de-energizing them is, you know where the disconnect is. That's why we have in the US, guys, in OSHA, thankfully, 70s and up, they start having rules for working energized. When you have an energized work permit, part of the permit is you have to identify all sources of disconnecting the power. So if somebody's working energized, he or she get electrocuted for whatever reason, you need to be able to walk into a source of power and disconnect the power immediately. That's part of the permit that you have to, at least six people are going to be signing off on it. Your manager, the maintenance, tons of people are going to have their names on that form. Shut off the source of power and CPR, administer CPR, false call 911, and timing is everything. You let somebody, you can survive a lot of shocks, it's a very short amount of time, but if it's longer, 120 volt for a long time can kill you. Any comments, guys, about these? So take these as guides when you become a project manager, really. Not a whole lot to them. You guys don't do tools. Not a whole lot of tools. Usually, typically, as engineers and designers, when I say you guys as designers, I'm a master electrician, worked for Bloom Engineers. We had a project downtown Minneapolis, and I was there as an engineer. And the company I work for is not licensed or bonded or insured as an electrical contractor. They're engineers. So if I go there, I'm a master electrician, remember, but I'm there under the capacity of being a designer, an engineer. So I'm not supposed to touch anything, because God forbid touch something and get killed, the insurance will not cover me. It's not part of my job description to go torque these lugs as an engineer. So be aware of that one, guys. There is a lot of issues. If you are there as an electrician is one thing. If you're there as an engineer, it's a whole different thing. So don't touch things that you're not supposed to. A couple of things, but as a project manager, you need to be aware of the proper tools that you have. We have fully voltage insulated tools that we work with when we work with energized equipment. You have to understand the difference between fully voltage insulated tools and non-insulated tools. And the second thing, of course, the meters that you have to do. We have a lot of meters, guys, that we can use. These meters are great. The best meters are the ones that can handle a lot of short circuit in them, so it doesn't explode right into your face. So here's two categories that you can pick for your employees. One is high fault current, very low fault current. Why? What's good about high fault current? If you have a fault current while you're holding that thing, this device is not going to explode in your face, the meter. So this is just a couple of things about tools. Again, I emphasize, number one, insulated tools as you work on energized equipment, and quality meters, digital multimeters that you use that can handle big amount of current is what you need. And I have a bunch of meters I usually don't bring in because you guys are not electricians, and we're not supposed to do that. If you want to meter as a designer, guys, you don't do your meters. You have to have an electrician do all this measurement for you. for liability issues. Any comments, any questions about that, guys? So that's, but as a project manager, you need to be able to do it. This is a lot of places where you can find training about OSHA training, guys. If you go to OSHA, tons of PowerPoint presentations about training and safety and so forth. Training seminars, we do training seminars. I told you I have one on YouTube for 4 hours about OSHA 70, about 70 NFPA. So you can go there and get a lot of training. Especially those of you guys, because we're designers, sometimes we take it. Electricity is dangerous, but obviously it's manageable, like everything else, guys. You drive your car is dangerous. Driving a car is dangerous. If you know how to handle it, it's not as dangerous as you should be. So the rule, remember a rule. Rule is lockout, tagout procedure. You de-energize every source of power and you work. If you follow the rule. Rule number 2, the exception is you work on energized objects. You have to put the proper PPE on you. Glasses, shield if needed, gloves, you name it. If you follow the rules, it's good. You will survive. So this is just a few things that to be aware and not to, I know you guys, a lot of you are in the field, so you're not going to be horsing around with electricity as we do. Licensing and permits. In the great state of Minnesota, in our state, to do electrical work, everybody knows that. You have to be aware of it. Probably you guys know it, but the electrical designers, you need to be licensed by the state as an electrical contractor. You need to be bonded by the state, have a big chunk of money, $25,000 minimum, in case you did not fulfill your obligation to the customers, and you have to be insured for close to $300,000, plus there's a bunch of definitions in case you burn the house. So there's a whole list that in our state, in order to practice electrical work as a contractor, you have to be licensed by the state as an electrical contractor, bonded and insured. That's the business part of it. The people part of it, in order to do work as a worker in the state of Minnesota, you have to be a licensed electrician, journeyman, if you're doing a new construction, maintenance if you're maintaining a system, a master electrician, if you are going to carry the license for the company, or you have to be working under a licensed electrician. And in our state, you can't work, like you guys are non-licensed, 2 of you, I can supervise no more than 2 as a master electrician or journeyman. If I want to bring a 3rd person, I have to bring my friend Jeff here or Derek, because they're journeymen. These are the rules. Who cares? When we do estimation, guys, later on, when you allocate your labor, you have to be aware of all these rules. You're going to allocate labor if you're going to be an estimator. You can't put cheap apprentices. I'm going to pay them $20 because there's rules and regulations they have to meet. So does that make sense? Where that they call it 2-to-1 ratio, 2 unlicensed to 1 licensed. You have to maintain by the state, and even if you do a union job, they're 1-to-1, or sometimes 2 journeymen to 1 non-licensed. They put it. This is just the bare minimum. The state rules is 2-to-1. Union go 2 journeymen to 1 apprentice, and even higher than that sometimes.
There's going to be pre-apprentices now too.
What?
There's going to be pre-apprentices now too.
Pre-apprentices.
Yeah, Local 110 last contract negotiation, they changed the language to allow pre-apprentices.
Okay, so cheaper, a little bit cheaper.
Pre-apprentices, apprentices, journeymen.
Yeah. But it's still, no matter what the IBW call them, still the rules of the state of Minnesota.
Still going to be ratio.
Absolutely. You see, there's the union rules and there's also the state rules. State is a law. The law says unlicensed, doesn't matter what you call it, unlicensed, licensed, 2-to-1. So, any comments, guys, about these? These are good to know as in our state to practice work permits. In the state of Minnesota, you have to pull a permit to do work. If you're an owner, you can pull a permit for the place that you homestead and work on, not the one that you rent. So be aware of that one. But for all the construction work that you have to do, you have to pull a permit from the state, pay your dues, and with the permit come inspection, 1 or 2 inspections that you have to do. So be very aware of that one. Okay, so that's your licensing and permits. If you have an engineered project, guys, we're going to have the construction plans and the prints and the drawings that we have, and that's what you guys are going to be working on. And that will move us into plans and specifications. Now we're moving into the engineering part of things. When we have an engineered project, guys, you're going to have a set of blueprints. You guys we're working on it yesterday. You're going to work on it all year. That you provide. These blueprints or drawings are based on the NEC code book, other ADA, for example, building code, the plans, not just the NEC code book, and sound engineering judgment. You will hear the word sound engineering judgment. So the NEC code book is bare minimum. So you might find you can put 10 receptacles on one 20 amp circuit. But if a sound engineering judgment said, well, why this building will live for 50 years? Do you really want to take a chance of tripping it? Look at the people who are going to maintain the system for 50 years from now. Do you really want to make their life miserable maintaining the system? So you might have to cut them from 10 receptacles to 5. Sound engineering judgment, higher than the code. That's when you get into the engineering, guys, you can see certain things much, much higher than the code. We go. So we have the blueprints, we have the specifications. We talked about the specification, guys, yesterday. A big set of specification that in detail describe all the electrical equipment that you're going to purchase and install in the building. And we'll be doing that one for this project. Prevent confusion of the details. If there is a plans difference, usually the specification will rule. If there's a difference between the spec and the plan spec rules, for example, in my specification I say MC minimum of MC cable required for this type of project. In the plans, if I say AC cable, and there's a difference, MC cable rule because specification rules it. So, and it becomes a, you know, we have the blueprints, big spec with it together. That's your contract to do the project, and all of them are based on this or higher, based on NEC code book or higher. We have symbols and notations. You guys are going to be coming with the symbols and notations. Yesterday we inputted all the symbols that we're going to be using. So you're going to be aware of that one. So you have a symbol and you have a notation right next to it, GFCI. So here's my receptacle, here's my GFCI receptacle. It's a receptacle, a duplicate receptacle, and it's a GFCI type. So these are, we're going to be doing tons of these. Why do we use symbols in the plans and specification? Because we don't want to write encyclopedias, right? Writing install a duplicate receptacle in this corner. Instead of doing that, we just throw a symbol like the one I showed before, and that every electrical professional, the engineer, designer, and electrician understand that this symbol is a receptacle. Simplifies the plans. Simplifies the plans. And the notification that comes with it, guys, obviously it adds more information into the project. More information into the project. Okay, any comments, any questions so far? Any comments? We will hash these guys more, the permits and so forth. We have a class in next year, calendar year. We do project management, we go over these in details as part of a project manager. A national electric code. I want you to be aware, especially the electrician, as when you come to me and say that here's a bare minimum that we're going to do. In the engineered project, don't do the bare minimum. As a matter of fact, a good engineered job will brag how higher than the code we go, not by how lower we can't, because it's the law, but how higher we can do that. So if you look at a plan and you find, and you have to find the happy medium. You can't overkill too. So that's where a good engineer, a good electrician, a good designer can find the happy medium between a good engineered project and also an affordable one. That's where you guys are going to come. Do I want to put a receptacle, a 20 amp circuit for every receptacle? So that might be overkilling, convenient receptacle, or should I put 5, or should I put 10? So maybe 5 is the happy medium between 1, 10, or 5. So that's where you guys are going to come. And hopefully I will lead you through this process when we go to the commercial industrial and give you a couple of rules of thumbs, industry standards, and so forth. You guys are familiar with NFPA, with the NFPA 70 NEC code book. In our state, 2011 is the latest and the greatest. Every 3 years we collect them. We update them. 2014 is coming. There's a few 2014 is up and running right now. So that's basically the NEC code book. We're going to be hashing it as we go through in terms of all the requirements that you need to do. IAEI, they're really great if you belong to them, guys. The International Association of Electrical Inspectors. You're going to be aware of those guys, especially as a designer project manager, because all the inspectors go to their training. So whatever they have in the training is whatever the inspector are going to be implementing in the field. And there's a lot of gray areas. So that's why they become really, really cool. If there's a gray area in the code, they try to explain it to the inspector. And why we care about the inspector? Bottom line, your project is going to be inspected by the city of Minneapolis inspectors or the state of Minnesota inspectors. So you want to be aware. The worst thing that you could do, guys, is you put a piece of equipment here. The inspector saying, "Oh, you can't put it here. You have to remove it." And you spend 3 days putting this piece of equipment. You lost 3 days worth of productivity for your workers. Now you're not electricians, but you are the project manager there. That's a bad day for you. So be very, very aware of that one, guys. And you can be a members of them. NEC, guys, we'll talk about NEC, made out of 9 chapters, as you guys know. Later on, we'll talk about this one. The first 4 chapters are, I would say, the bread and the butter of the NEC code book is in the first 4 chapters. The last, the first 4 chapters, the last 5 chapters is special equipment, special conditions, special locations, and low voltage, plus a couple of tables. And we will talk about this. I happen to design based on a lot of system myself, guys. And I always say one little thing, and I know you guys do it in IBW, and we do it in the apprenticeship. I don't think you guys did it with us here. There's one little thing you have to understand. There's 100 definitions in any secret book must understand before you go. And you guys give it to, I think they gave it to you guys in 110. So there's a lot of 100 definitions. You have to, before you even open any secret book, you have to understand it as an apprentice. Now, as a designer, I add to that. I said, before you read any secret book, you must read Article 100 and read every single definition and understand it. So, grounded conductor, bonding conductor, GFCI, line to ground voltage, line to line voltage. How does the code define it? Clearances around electrical equipment. You have to read the Article 100 if you want to be proficient in any secret book, period. So if I have an advice for you, before we start any secret book, take a few seconds and just read through the definitions. Read through them. You might not understand all of them, and you shouldn't, but at least read through them. You know where they are. We use 2011, as you guys know. A lot of other states use different older versions. And be aware that other building codes or other standards might restrict you from doing certain things. So other communities might restrict you from using NM cable. So the good designer, guys, you learn this from experience. If you go to a city that you're not familiar with, in the US, you're going to do work there or design project there, and you're going to use an MC cable for your project because it's cheaper or easier than putting conduits and so forth. Make sure you visit that city's website, the construction department, and see if they have certain rules or regulations. Give them a call. A good designer, you're the designer. Well, if you're not familiar with the city or the area that you work on, if you're familiar with it, not a big deal. Like in Minnesota, we're all familiar with a lot of other places, with the places, but it's still a really good idea to visit and see if they have other regulations. For example, you can't use MC cable, you have to use EMT everywhere. So that will make a big difference in what you do. A big difference in what you do. Okay. This is I don't know how many of you guys are familiar with this document. For existing building, NFPA has a little code that goes through how to inspect and work on an existing building and identify the hazards for existing building. Not a big deal for you. You guys are, other than maybe I can see you as a project manager walk into an apartment and evaluate. They want you to evaluate the electrical safety of this building for your company, so you can bring your crew and bring it up to code. This would be a good document. Residential only. Anybody have seen that document? Residential only. So it really grabs a lot of good stuff from the NEC code too. So be aware of that one. Code organization that you have to be with. You guys are designers and engineers building code. You're going to have the international, this one, and ANSI. These are big names in the building code and the Minnesota building code too. We go through it. It gets complicated when it comes to the building code, guys, and that's where you work as a team in an engineering firm. There's a lot of building code you have to adhere to. So we keep at this level, you keep focused just electrically only, kind of, otherwise you get into all the mechanical and the structural interaction and the building. It gets a little bit complicated, just be aware of that. ANSI, we have a lot of rules for ANSI. You have to be aware of it. The only thing I want to mention is they do this one all the time. If you guys remember what we said, rule number one when you electrical safety. What's rule number one of electrical safety? Listed equipment, listed and labeled equipment, safe equipment. This is directly from the NDC code book. Your equipment, before you install it, have to be listed by a third-party verification, as well as labeled. Attach a label to it to say, yup, this switchgear can handle 50,000 amp short circuit in it. And we tested it as a UL, and we put a sticker on it as 50,000 amp withstand rating. I can't do that as an engineer even. So that's why in any secret book, big deal, listing and labeling, and the equipment that's listed and labeled have to be installed, operated according to the listing and labeling. For example, this fixture is listed and labeled to be indoor fixture. Can I put outdoor? No. So that's basically what the listing and labeling. You have to install them, follow the instruction of the manufacturers, and install them based on their listing and labeling. It says indoor, outdoor, and so forth. So that's your couple of building code. The last thing I will let you guys read through them is the metric system in the NEC code book. You're familiar, I don't know if you guys are familiar or paid attention to, you can do your calculation based on foot, square feet, or based on square meters. Very few people do that. Metric system is closer than what you think. We did in Minneapolis, we did calculation in Brazil for project American companies in Brazil and South America, and we did all the calculation based on the metric system here in Minneapolis. So you might be surprised, when am I going to be using this system? Certain government building will use a metric system. So when you don't be surprised when you see meters, so be aware that I can do calculation based on the meter system here. And there's a couple of multipliers, you guys will read them and get familiar with. The last thing I want to mention is third-party verification. I call them third-party verification because safety and safe around electrical equipment start with the equipment that you install. It has to be safe equipment. But if you're making a switchgear, do you think I trust your words that your switchgear is good? Should I trust the word of the manufacturer that their switchgear is good? Well, remember what Reagan said about the Russian. They said, trust, but what? Verify. So you're going to trust, but verify. How are you going to verify? You have to have you can't verify your work. You have to have a third-party verification. That's where all these, they call them nationally recognized testing laboratories, a big collective umbrella of organization, nationally recognized testing laboratories. Those guys have smart people hired and big facilities where they blow up things like you have. Their job is blowing up things. You have a light like this, you think the ballast is going to handle 120 with fluctuation 10% up and down. Yep, so they'll go pump 10% higher voltage and see what's going to happen to the ballast for 5 hours. Is it going to blow up? So that's how and then if it doesn't, based on the specification, they give it a label. So that's why when you install equipment and the specification that we have engineers, we say everything has to be listed and labeled by a third-party verification. Okay, the notoriously famous one is UL. We all know familiar with it. NC is a big deal. They do switch gears, guys. So those guys, they hire a lot of people. They sit them in a building, very smart, and they test the equipment and make sure that the equipment will operate within the parameters that the manufacturer says it's going to operate with. If the manufacturer say it's 50,000 amp interrupting rating, they don't put 60 in it though. They put 50. You know what I mean? And then they label it as 50. So that's a big deal. So they make sure that it complies with the standard. And then they give it a listing like this UL listing, as you guys can looking at it here. So what do? Products are tested for safety, and they they test it once, and then periodically they go and pull a certain switchgear and test it to make sure it's continue to be safe equipment, as well as they put them in a list and they give them a label. A bunch of them are there, guys. UL, CSA, the Canadian Standard Association, is another one. NEMA, notoriously NEMA. NEMA 1, 2, 3, the sizes of the contactors. Interlect Testing Services is the third one. So these are all, you're going to find labels. So what's in it for you guys? Just be familiar slightly with the names. So you see it, NEMA, good. UL, good. If you see a name, if you see CSK verification, question mark, that's my initials. You know what I mean? So if you see any of these, again, with the internet now, you can research them and all the stuff. So if any of these names are well recognized, testing laboratories, otherwise, you might not be able to get what you need out of this product. Any comments, guys? Any questions about this? So to summarize, as I said, safety starts with safe equipment UL. Then you design it and install it based on NEC code book. That's safe equipment design and installation. Then you work on the equipment safely based on 70E. That's for arc flash and blast and all the stuff. Then you maintain the equipment based on 70B. Then you're done. Then you're electrically safe. You have an electrically safe system. When you, Jamie, become a designer and an engineer, your job is to design a safe project for the customers. That's your job. That's going to be safe and work efficiently for 50 years from now. That's in the back of you, not tomorrow, not today. You, as a designer, our job is for the system to work efficiently, safe first, and efficiently today and 50 years from now. So that's where you guys recommend what? You design by 70 UL first, right? Listing, design based on NEC code book. Then you tell them about 70E so they can work safe because you don't want to kill them working on the electrical equipment. And you tell them about 70B, where this is how you guys maintain my switch gear after I leave. That's where you become a good engineer, good designer. Any comments, any question? Yes, sir. Please do.
Who decides like what switch gear you use on the project?
We.
You?
We.
Okay.
You're gonna be the guy.
Yeah.
That's why you're here. That's where we're gonna go as we move on, guys. We're gonna tell you what's the difference. I don't know how many of you know the difference between load center, panel boards, switchboards, switch gears. All these words that we use. That's as we move through the years, you're gonna see. And which one of them is good for the job that I'm handling? It's a big deal. That's all what I have. Any question, guys? Any comments? Cool. So please read these chapters. They're really good chapters. Read them. I know there's a lot of ins and outs and all this stuff. But remember, you are going to be project managers at one time. And this information is vital to know. You don't have to memorize everything, but know it. Cool? Let's take 5 minutes and then we'll jump into CAD. If you guys don't mind. Yes, sir?
You're going to be splitting this up. Should we set another folder?
Just hold on until the end of the day. See how, if he's going to show up or not first before we... Yeah. Let's continue as is, and then we'll cross that bridge when we reach it. I know you want to be proactive. Let's just, we can easily pull them. I'll pull them for you. Not a big deal. Thank you.